Alright, so this is Deductive Structure and 1.7 in your books. So let's dive right into it. So the structure of geometry is based on deductive structure. It's a system of thought in which conclusions are justified by means of previously assumed or proved statements. Okay, that's huge right there because a lot of what you're going to be doing in this class is proving statements and doing proofs. So that's important. Every deductive structure contains the following four elements. So this is important to understand. Undefined terms, assumptions, which we're going to call postulates, definitions, and theorems and other conclusions. So those four things are part of every deductive structure. Okay, so undefined terms are often just terms that we describe, but we don't formally define. So, for example, point and line, when we went over that, we described them, but we didn't really actually define them. So that's going to happen sometimes. Next, we have postulates. Now, to date, we haven't formally presented any postulates. We have used some algebraic postulates in solving problems. But we're going to get into what they are. A postulate is an unproven assumption. A lot of times you just have to accept it for what it is because the proof in doing it is much more difficult than actually just saying, okay, this is this. And that only works for postulates. We'll spend a lot of time proving theorems just so that you understand how and why they work. In the book, postulates are going to be preceded by the heading postulate, so you'll know when we're talking about a postulate versus a definition or theorem. Which brings me to my next point, definitions. You guys have an idea of what a definition is. In geometry, it states the meaning of a term or idea, so pretty much the same as in English or anywhere else. Again, definitions are going to be marked in these presentations or in your book. Preceded by the word definition, so again, you know what it is, because there's some characteristics of definitions in geometry that's important to understand, especially when you're doing proofs. Okay, in geometry, definitions are reversible. So, for example, if the measure of a right angle, or if the measure of an angle is less than 90 degrees, then it is an acute angle. So that's basically the definition of an acute angle, is that its angle measure is less than 90 degrees. So again, if an angle is acute, then the measure of an angle is less than 90 degrees. And when we get into the proofs, you'll see why this is important. But for now, just understand that the word or the concept and then the definition of that is interchangeable. Okay? Alright, continuing on with definitions. In some problems, the first example of a definition of an accurate angle might be used, while others may require it to be in the form of the second. You're like, huh? So example. Definitions are usually stated if P, then Q, and P and Q are just interchangeable with whatever it is, where P and Q are kind of declarative statements. So this is a conditional statement or an implication. So the if part of the sentence is called the hypothesis, and the then part is called the conclusion. So you can also symbolize if P, then Q with this right here by using this arrow. So the arrow looks like this. So if you were to say if P then Q, just write P, this arrow, and then Q. The converse of if P then Q is if Q then P. Okay, to write a converse, all you have to do is reverse the letters or the parts as in the example. So like we would read this if P then Q, and because this is a definition, we could accurately say if Q then P. Alright. And now we move on to theorems, which you are going to see a lot of in this class. Theorem is a mathematical statement that can be proved. In this course, all theorems will be numbered for ease of reference only and preceded by a heading such as Theorem 78. I said that it's for ease of reference only because when you're writing out theorems and you're using that as a justification in a proof, you cannot just say Theorem 78. You have to state in some way, shape, or form what the theorem states. So theorems are going to be proven by using conclusions previously assumed or proved. You cannot use one theorem to prove another. You can't use the theorem to prove a theorem, if that makes sense. You basically can't use what you're trying to prove as your means for proving it. So theorems and postulates are not always reversible. So for example, one postulate is if two angles are right angles, then they are congruent. However, the converse of that, if two angles are congruent, then they are right angles, is not necessarily true. They could be right angles, but they could be two angles that both measure 30 degrees, which aren't right angles. So the first statement is absolutely true. Okay, if two angles are right angles, then they are congruent because right angles have a measure of 90. The second one isn't necessarily false, but it could be. For something to be true, it has to be true all the time. So when I say something's true or false, that's what I'm talking about. Yay! Okay, so let's move on to the first example. State the converse of each of the following statements and tell whether the converse is true or false. So we've got, if an angle contains 90 degrees, it is a right angle. And if Mary received a B on her math test, then she passed the test. So pause it, and I want you to write the converse of each of these and then state whether it's true or not. Then press play and see if you were right. All right, so let's move on to the answers. So all I did is I took this second part and flipped it. So if an angle is a right angle, that was this, which is now here, then it contains 90 degrees. So that was that, which is now there. So basically they flip-flopped. So is that true or not? If an angle contains 90 degrees, it's a right angle. If an angle is a right angle, then it contains 90 degrees. So that's true. However, for the second one, if Mary passed the test, then she received a B on the test. So again, all I did was take the two parts and flip-flop them down here. Now let's see if it's true or not. So if she passed the test, then she received a B. Well, that could be true. However, because she also could have received an A, a C, or D, we say that that's false, because for something to be true, it has to be true all the time in all examples. And that's it. So not too bad. If you want to get ahead, 1.8 will be up shortly.